Hi everyone, welcome. You ever stop and think about how the AI in your life actually works? You know, the thing that recommends your next favorite movie or zaps that annoying spam email before you even see it? Well, it's not some magic black box. It's a whole process. A journey, really. And today, we're going to walk through that entire journey, the machine learning pipeline. So yeah, it really all boils down to this question. How do you go from just an idea, a simple what if, to a full-blown AI system that can actually predict what's going to happen next? That's the puzzle we're putting together today. We're going to map out the whole path for you. And the answer, the map for this journey, is what we call the machine learning pipeline. Now, don't think of this as some boring technical checklist. It's more like a recipe or a roadmap. It takes you all the way from a mountain of messy, raw data to a smart, polished AI that's out there making real decisions. And trust me, getting your head around this big picture is absolutely the key. Okay, so we're going to break this whole thing down into three big chunks. First up, we've got to lay the foundation. Then we get to the really cool part, building the brain. And finally, we set our creation free, into the wild. All right, let's dive into phase one, the foundation. And this is exactly what it sounds like. You wouldn't build a skyscraper on sand, right? Same idea here. A successful AI needs a rock-solid base. If you get this part right, you'll save yourself so much headache down the line. It's crucial. And step one, before you write a single line of code, before you even look at a spreadsheet, is defining the problem. Simple as that. You have to know, with crystal clarity, what you are trying to solve. So what is it? Are we trying to guess what a house is worth? Or maybe figure out if an email is junk? What about recommending the perfect video for someone to watch? Whatever it is, you need a specific goal. Think of it as your North Star. It's what guides every single decision you'll make from here on out. Okay, problem defined. Now what? Well, you need fuel for your engine. And for AI, that fuel is data. Lots and lots of data. This is where you go on a hunt, gathering up all the info you need from databases, user logs, public sources, wherever it lives. And remember, the quality and the amount of data you get, that's going to directly decide just how smart your AI can be. All right, now, for the part that, let's be honest, can be a real grind. It's often the most time-consuming step in the whole pipeline, data cleaning. See, raw data is never perfect. It's messy. It's got duplicates, blank spots, weird formatting, just a total mess. This step is all about rolling up your sleeves and tidying all of that up so it's actually usable. There's a saying in this field, garbage in, garbage out. And it's 100% true. You could have the smartest, most powerful algorithm on the planet, but if you feed it junk data, you're going to get junk predictions. It's that simple. Clean, high-quality data is the bedrock. Everything else is built on top of it. Okay, so our foundation is solid. The data is clean. Now we get to move on to phase two, building the brain. This is where the real fun begins. It's the part where the learning and machine learning actually happens. All that hard prep work is about to pay off. First up in this phase is something called feature engineering. Sounds technical, but the idea is simple. Think of features as the clues you give your model to work with. If we're predicting house prices, the clues might be things like how many bedrooms, what's the square footage, what neighborhood is it in. This step is all about picking the best possible clues, and sometimes even inventing new ones, to make it easier for the model to spot the patterns. Next, we do something that might sound a little weird at first. We take our beautiful, clean data and we hide some of it from the model. We split it up. Why? Well, this is absolutely critical. We need to make sure our model is actually learning the underlying patterns, not just memorizing the answers like a student cramming for a test. And a common way to split it looks something like this. You take a big chunk, say 70%, and that becomes your training data. This is like the textbook the model gets to study. Then you hold back two smaller pieces. One is for validation, think of that like pop quizzes along the way, and the last piece is the testing data. That's the final exam. It's totally new stuff the model has never seen before, and it's how we find out if it really knows its stuff. So our data is prepped and split. Now it's time to pick our student, the model itself. This is where we choose a specific algorithm, maybe something like a linear regression model or a more complex neural network. And the key thing to remember here is that there's no single best model for everything. It's not one size fits all. The right choice totally depends on your specific problem, your data, and what you're trying to achieve. All right, let's get to it. Class is officially in session. This is model training. The model takes a look at our training data, makes a guess, and then checks its work against the right answer. If it's wrong, it adjusts itself just a little bit to do better next time. And it does this again and again and again. We're talking thousands, even millions of times, over and over, until it starts to really nail down the hidden patterns in that data. So our model is trained. It's learned. Awesome. But, a model that just sits on a computer in a lab isn't really doing anyone any good. So that brings us to the final phase. Phase 3, into the wild. This is the moment of truth. This is where we see if our AI can actually handle the real world. So, how do we know if it's any good? Well, it's time for that final exam. Remember that testing data we carefully hid away? Now's the time to use it. We show the model this data it has never seen before, and we grade it. We use metrics like accuracy to see how well it performs. This gives us a really honest picture of how it's going to do out there with brand new, real-world information. And a big part of evaluation is understanding that there are almost always trade-offs. You might have one model that's incredibly accurate. It gets things right almost all the time, but it's slow as molasses. Then you might have another model that's a tiny bit less accurate, but it's lightning fast. If you're building, say, a real-time system, speed might actually be more important than getting that last fraction of a percent of accuracy. So, based on what we learned from that evaluation, we go back and fine-tune the model. Think of it like being a sound engineer at a mixing board. You're tweaking all the little knobs and dials, these are called hyperparameters, to get the sound just right. You're trying to squeeze out every last drop of performance to find that perfect balance of accuracy, speed, and whatever else matters for your project. And now, the moment we've all been working towards, deployment. This is the big one. This is when we take our finely tuned model and plug it into a real, live application. It's out there in the world, making predictions for actual users. This is where all that hard work finally pays off, and our AI starts delivering real value. But wait, we're not done. The journey doesn't just stop at deployment. Think about it. The world is always changing. People's habits change, new trends emerge, and your model can slowly become out of date. Its performance can actually get worse over time. That's why you have to constantly monitor it, keep an eye on it, and be ready to retrain it with new data to make sure it stays sharp and effective. And that really brings us to the main takeaway here. The machine learning pipeline isn't a straight road with a big finish banner at the end. It's actually a circle. It's a continuous loop of building, launching, watching, learning, and then improving. It's a never-ending journey. So if you take one thing away from this, let it be this. Before you get lost in the weeds of complex algorithms or the latest fancy tools, really take the time to understand this pipeline. Grasping this whole workflow from A to Z is what separates the amateurs from the pros. It's what lets you truly think and build like a real machine learning practitioner. So there you have it. We've laid out the entire map, the complete journey from a spark of an idea to a fully functioning AI. We've given you the blueprint. The only question left is, what are you going to build with it?